SpaceX is racing towards Starship Flight 12, and Booster 19 is doing nothing short of an impossible test run, and it is acing it. But will this be enough to achieve all the important goals SpaceX's Starship must master for NASA and our renewed race to the moon against China? Why did I go on a drive to find SpaceX's new ray gun? Why does SLS keep running into leak problems? And have you ever seen a 99-ton carbon fiber robot building rockets? My name is Felix, welcome to What About It. Let's dive right in. Starship updates. How are we even supposed to keep up with all the news coming out about mega projects, Kardashev civilizations, starships, moon landings? Let's try to do this one more time. SpaceX's Starship is getting ready for Flight 12 rapidly. The most important topic here is Booster 19. It's a juggernaut. Super Heavies are, as the name implies, the largest rocket boosters ever built. This time, things are different though. Booster 19 isn't like anything SpaceX has ever flown before. The last generation of boosters was wildly different in almost every aspect. A fundamentally different design. And that's why SpaceX is not letting this booster go. It is testing at Massey's. Since its arrival at the Massey test site, it has conducted tests on a daily basis. Tests of epic proportion. I have honestly never seen a booster this frosty. SpaceX keeps repeating these tests to see if there is anything wrong with this new and completely different design. If you'd cut them open, SpaceX has already done that. Just look at the difference in the engine section alone. So they test and test. Ambient pressure tests, for example, filling it with ambient temperature gas to check for leaks. Sometimes Jordan even catches an announcement on the Massey's PA.
On the booster stand, loud pressing of the booster and fuel tank, loud pressing of the booster fuel tank.
This is often the only way we can know fast enough what's actually happening. And then they're already going for another cryo test, then another ambient temperature test, and so on. This spectacular scene was captured by Jordan on February 6th. It is the so-called depress vent, often signaling the end of a test. All the vents are opened, pressure rushes out, ice falls off the booster, vapor clouds sink down. It is amazing to watch. And besides being amazing to watch, it hasn't shown any visible problems so far. Booster 19 is marching through these tests, seemingly unimpressed. And that is an excellent sign for us. It shows that Starship version 3 might be more ready than we thought after the Booster 18 rupture. I mean, seriously, 18 ruptured the day it was brought out to Massey's. Because of a COPV rupture, something not even related to the design itself. And SpaceX is fixing things, not just at the test stand itself. They've acquired Hexagon Purus ASA's aerospace subsidiary for $15 million, furthering SpaceX's vertical integration. That is the company that manufactured the COPVs for SpaceX before. Now they're integrated into SpaceX, which makes cooperation way easier. And it'll hopefully raise the quality of the tanks. That's the entire philosophy behind vertical integration, as it's called. Integrate every part of your design into your own company and avoid communication problems along the way. Now, SpaceX doesn't buy a product anymore. The engineers work directly on the project, supplying a component in-house and perfectly adapted to this special use case. In return, this implies that the issues with the COPVs might not just have been ground handling problems after all. Hexagon supplied high-pressure composite storage cylinders for aerospace and space launch applications before. Now they'll make them specifically for Starship and other SpaceX use cases. And we're not done. SpaceX is doing it all at the same time. Ship 40 is in active stacking. As can be seen on Avid Space's cameras, its forward dome, or FX4, has been moved into Megabay 2 for stacking with the N3, which is the forward section of the ship's main tanks. So while Ship 39 is still waiting for its test campaign, Ship 40 is already in active production and far along. Let's keep going. Booster 20, the one to fly after Booster 19, is making progress as well in Megabay 1. The common dome was moved into the bay in the early morning hours on February 6th, as can be seen on Avid Space's cameras. Stack, stack, stack. Starship needs boosters. On we go with Raptor 3 engines, a very important component of any static fire or flight activity. Never ignited at Starbase before, SpaceX has just broken through 100 manufactured engines. Raptor 102 was sighted by NSF at the McGregor test facility. So it's safe to say that SpaceX now definitely has enough of them to outfit the first Starship version 3 full stack. Reason enough to do a comparison. Raptor 3 isn't just sleeker looking, let's put them in a race. But first, let's talk about another kind of race we must win. There is a real and growing problem: endless spam emails and phone calls. Today's sponsor Incogni can help you just like it does for me. Let it make this constant nuisance stop. Ruthless data brokers sold my personal data, but those days are over now. You are not alone looking for better data protection. Half of all Americans do. Incogni can do for you what it is doing for me, and it is easy. Let Incogni handle your data privacy needs. Simply sign up and grant Incogni permission to track down data brokers. That's it. Incogni is now effortlessly running in the background automatically, ensuring your personal data truly remains personal. Now, with Incogni's custom removal feature, if you find a website with your information, just copy the link, send it over to Incogni, and they will remove it for you. Your personal data bodyguard. Join me at incogni.com/Felix. Take control of your personal data with Incogni. Use code Felix at the link below to get 60% off an annual plan. I love this special offer, it makes a huge difference. That's incogni.com/Felix to enjoy personal privacy while supporting Y. Alright, back to our little Raptor race. Sea level thrust for Raptor 2, which flew up to Flight 11, is estimated at 230 metric tons of force. Raptor 3 goes up by 22% and does around 280 metric tons, maybe even more. The combustion chamber pressure went up by at least 10% from 300 bar on Raptor 2 to 330 bar on Raptor 3. Some tests even reached 350 bar, but those are unlikely to be flight scenarios. Specific impulse at sea level, so the fuel economy of the engine went from roughly 330 seconds to roughly 350. That's an increase of 5% and maybe the most important metric to change, because it results in this. Mass flow on Raptor 2 was around 1600 to 1700 kilograms per second. On Raptor 3, it's 1900 to 2000 kilograms per second, but with a better ISP, this results in roughly 4% less fuel per ton of thrust. Its dry mass, thanks to cutting all the clutter, went from roughly 1630 kilograms to 1525, which makes it around 7% lighter, even though it produces more thrust at a better specific impulse. Add to that, no separate heat shielding required thanks to regenerative cooling on the powerhead, a roughly 75% reduction in joints, a higher out-of-the-box reusability rate. SpaceX set a goal of 100 plus launches per engine. Of course, take those numbers with a grain of salt, as it is really hard to get real numbers, but it gives you a good idea of where this is heading. Musk recently stated that Raptor 4 will have to hit 300 metric tons of force for the 33 engines to generate a collective 10,000 tons of force. So Raptor 3 is clearly not the end of the development, but a huge step away from Raptor 2, and they just showed an engine number past 100. That is incredible on its own. And we went up in the air again. Jordan has been flying more and more thanks to your support. Take a moment to like and subscribe. And if you want to go the whole 9 yards and be a direct supporter, go to our Patreon page or become a channel member right here on YouTube. It is what enables us to do all this. Thank you, you rock. Jordan saw the progress from above again. Looking at Pad 2 shows the state of progress. There's still some scaffolding up on the pad and some on the tower itself, but it is becoming less and less. Work is finishing up. The flame diverter now has almost all the piping needed for a first static fire test. Some cladding on the tower is still missing, lying next to the tower foundation, but that should only be important for the launch itself. Everything looks cleaner and cleaner. One thing is sticking out though, literally. Take a look at this line here. It's a slick wall. Jordan also took pictures from the ground. This ongoing construction effort marks the beginning of the largest expansion the Starbase launch site has ever seen. SpaceX is going to expand the facility's footprint to accommodate the second pad. I mean the first one. It's in advanced stages of being rebuilt in the image of Pad 2 to accommodate Starship version 3 and later version 4. It's the transition from test launches to regular launch operations which SpaceX wants to tackle in 2026. The plans include Starship staging areas for Pads 1 and 2, extensive ground support equipment staging areas, and nitrogen liquefaction facilities to recycle as many commodities as possible. It also includes a spot for the new deflector farm for Pad 1, the water and pressure tanks needed to drive the deluge system for the upgraded pad. Blast walls will separate these facilities from the pads. And then there's this notch on the south side. It is labeled with LCH4 generation, which of course stands for liquid methane. And it is labeled as generation, meaning it will be produced there. If this is correct, combined with the growing air separation unit on the north side, this will provide SpaceX with on-site production of all major commodities needed for a Starship launch. And the best thing? Construction work is already underway. So in 2026, prepare for this site to turn into a massive construction site once again as SpaceX shifts from prototyping to regular Starship launch operations. That does have a ring to it, but we're not done yet. Here's the next big news after a shout for our epic friends at Redline. If you want to see how SpaceX is doing at Starbase from the air, just like Jordan does, visit redlineheli.com/Felix. $25 off for anyone using the link. The Redline helicopter team will show you the same Starbase views our photographer gets on his Starbase flights. Incredible views. SpaceX has acquired a massive ray gun. Prepare for an attack. Yeah, you thought I was joking about the ray gun in the intro, right? Maybe not. Ray gun! At least that's what a traditional news headline would have read. Michael Nichols, Vice President of Starlink Engineering at SpaceX, posted this on February 6th. I went and took a look personally. No ray guns visible. They're hiring elite engineers at their new 230 MeV or Mega Electron Volt cyclotron facility in Florida, where they are bringing single-event radiation testing in-house to accelerate development across all SpaceX vehicles. And if there was any doubt about SpaceX's orbital data center plan, this is where it disappears. In radiation effects testing, 230 MeV protons provide high-energy particles that simulate cosmic ray environments, helping test satellites, spacecraft, and avionics for radiation hardness. In short, SpaceX is working to harden its spacecraft and other equipment for deep space missions. So anything outside low Earth orbit, like AI data centers, starships going to the moon or Mars. SpaceX acquired a mostly completed 230 MeV cyclotron originally built for a proton therapy cancer treatment center in Winter Garden near Orlando. Again, in-house, same as the COPVs. This reduces communication lag between engineers from different departments and ensures a seamless process. Smart. And they are hiring. So if you're a ray gun specialist, go apply and help build our future in space. And in Florida, NASA is trying to understand a hydrogen leak. When NASA's Artemis II moon rocket hit a problem, it reminded many of similar issues in the Artemis I mission. The cause was a hydrogen leak near the base of the rocket. But why does the SLS keep running into leaking problems? Hydrogen is extremely difficult to contain. It's the smallest molecule in the universe, and even tiny leaks are dangerous because they can build up invisibly and ignite without warning. So when sensors detect a leak at the base of the Space Launch System, the software shut everything down. The interesting question is, what does NASA do next? They can try to fix the problem right there at the pad. Or they can roll the entire rocket back to the vehicle assembly building, the massive hangar where the SLS is stacked and serviced. And while a rollback sounds simple, it is anything but. The Artemis II SLS rocket sits on top of a mobile launcher platform the size of a building. Going to the launch pad and the VAB takes half a day, and that's just the drive. Once inside the building, engineers have to partially disassemble hardware, inspect seals and connections, perform repairs, retest systems, and then repeat the entire process in reverse. One rollback can cost weeks, sometimes months, and NASA has been down this road before. During Artemis I testing back in 2022, hydrogen leaks appeared at this exact same location. What followed was a brutal cycle, 3 separate rollbacks, 6 months of delays, and a test campaign that dragged on until the uncrewed mission finally launched in November of the same year. That history is what makes this latest leak so uncomfortable. For now, NASA is inspecting the hardware, analyzing data from the rehearsal, and deciding whether another wet dress rehearsal is needed before committing to a launch attempt. If the SLS can stay on the pad, Artemis II stays on track with only a modest delay. If it can't, history risks repeating itself. We keep our fingers crossed for a swift solution. Go NASA! While NASA is getting ready to make history again, a private company is creating its own legacy. A 99-ton robot laying carbon fiber at 100 meters per minute. over 100 spacecraft deployed into orbit without a single failure, and a brand new launch pad built in under 2 years on a quiet island. This is Rocket Lab, a company that started out launching small rockets and is now quietly turning itself into something much bigger. And to understand where Rocket Lab is going next, we need to start with the most ambitious project the company has ever built. With Neutron, Rocket Lab is doing something almost nobody else in the launch industry dared to do. They are building almost the entire rocket out of carbon composite. Not stainless steel like SpaceX's Starship, not aluminum like Atlas or Ariane. Carbon fiber, the same class of material used in Formula 1 cars and fighter jets. Carbon composite is incredibly strong and incredibly light, but only if you manufacture it perfectly. And Neutron is big. Its first stage is 7 meters in diameter. That makes it the largest carbon composite rocket structure ever attempted. To build something like that at scale, Rocket Lab needed a machine unlike anything they had ever used before. So they had one custom built by Electro Impact, a top-tier aerospace automation company out of Washington State. Inside Rocket Lab's Space Structures complex in Maryland sits what is now the world's largest automated fiber placement machine of its kind. It weighs 99 tons, it stands nearly 12 meters tall, and it moves like a slow, deliberate industrial animal across a factory floor. The machine lays down dozens of ultra-thin carbon fiber strands at once onto a rotating mold. As it moves, it presses them into place with rollers and applies heat so the resin becomes tacky and locks everything together. Layer after layer, each one laid at carefully chosen angles, building strength in every direction. Think of it like high-tech plywood, except every single layer is engineered by software for maximum performance. The result is staggering speed and precision. Before this machine existed, building a large composite rocket structure meant weeks of manual labor by skilled technicians carefully laying fiber by hand. Now, components like a Neutron second stage dome can be produced in roughly 24 hours. Across Neutron's production process, Rocket Lab estimates this one machine will save over 150,000 manufacturing hours. And it gets better. The AFP system inspects every layer in real time. If it detects even microscopic defects, they are caught immediately, before the next layer goes down. That kind of quality control is critical when you're building a rocket designed not just to fly once, but to land and then fly again. This manufacturing approach ties directly into Peter Beck's core philosophy. He's argued for years that many rockets fall into what he calls a circle of doom. Heavy structures demand more powerful engines. More powerful engines add complexity and cost, and suddenly your rocket is expensive, fragile, and slow to build. Carbon composite breaks that cycle. If your structure is extremely mass efficient, you don't need monster engines to compensate. That opens the door to design choices other rockets simply can't afford. But while Neutron grabs most of the headlines, Rocket Lab has quietly been winning somewhere else, in a part of spaceflight almost nobody talks about. Separation systems. In 2025, Rocket Lab's separation hardware successfully deployed more than 100 spacecraft into orbit. 0 failures. That shattered the company's previous annual record, and here's the key detail that is often missed. Those satellites didn't all fly on Rocket Lab rockets. Rocket Lab sells separation systems to the entire launch industry, including competitors. So, what is a separation system? It's the mechanical device that does 2 critical jobs. First, it holds a satellite firmly in place during a launch through violent vibrations, deafening noise, and crushing G-forces. Then, at exactly the right moment, it releases that satellite cleanly into orbit. In the industry, they are simply called pushers, because that's exactly what they do, push the spacecraft away from the rocket. Traditionally, many rockets used pyrotechnic systems, explosive bolts that fire to release the payload. They are light and fast, but they create shocks and can damage sensitive instruments, and they can't be fully tested before flight. Spring-based systems are simpler, but they offer limited control. They solely rely on the energy that is stored in the springs. Rocket Lab dominates a third category, motorized separation systems. That capability came from its acquisition of Planetary Systems Corporation in 2021, and specifically from a product called the Light Band. Mechanically, the Light Band is beautifully simple. Two metal rings are clamped together by a retaining ring. When separation is commanded, dual redundant electric motors drive a mechanism that snaps the retaining ring inward in just 75 milliseconds. Spring plungers then gently push the two halves apart and the satellite is free. There are no explosives, no consumables, no sliding friction surfaces. The system can be tested, reset, and tested again before flight. Integration takes less than 5 minutes. It is safe, clean, and extremely reliable. Simply clever. The Light Band supports payloads up to 800 kilograms, comes in multiple sizes, and holds a NASA technology readiness level of 9. The highest possible rating. It has flown on rockets like Falcon 9 and Ariane, meaning even Rocket Lab's competitors trust it with their payloads. Breaking 100 flawless separations in a single year doesn't just mark a company milestone. It confirms Rocket Lab's role as critical infrastructure for the entire global launch industry. And this is where it all comes together, literally. Rocket Lab built Launch Complex 3 right next to its existing Electron pad at NASA's Wallops Flight Facility on the Virginia coast. The two pads sit just a couple hundred meters apart on a narrow barrier island, and choosing Wallops over Cape Canaveral was completely deliberate. As Peter Beck put it, the Cape is an amazing place, but it is busy, and it is only getting busier. Cape Canaveral hosts SpaceX, ULA, Blue Origin, and a growing list of others, all competing for range time. Wallops, by contrast, historically saw only a handful of launches per year. That gives Rocket Lab something incredibly valuable: priority access, flexible scheduling, and fast turnaround. Exactly what you want if your business depends on high launch cadence. It also didn't hurt that Wallops already had much of the infrastructure Rocket Lab needed: fueling systems, range services, and logistics. The state of Virginia backed the project with roughly $45 million in support, helping fund the launch pad and a nearby production facility. And critically, building Neutron in Virginia means Rocket Lab doesn't have to ship a 7-meter diameter carbon composite rocket across the country. As Beck joked, we didn't want to define the diameter by the largest bridge between Wallops and California. Everything is co-located. Rockets are manufactured, integrated, launched, recovered, and refurbished within minutes of each other. This is Rocket Lab's philosophy of maximum independence in physical form. The company already produces roughly 95% of Electron in-house. Neutron extends that same vertical integration to a medium-lift rocket. And that's it for today. Smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our brand new Raptor emblem design and countless others are there for you to explore. Click the card or the US or worldwide link in the description. And if you want to know how SpaceX managed to build Raptor 3, the new Starship powerhouse, and what makes it special, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode.